I saw this video on YouTube and found it very intriguing, was perplexed by it, so I decided to try to solve it myself. And I looked at what they were doing with the foam core board and realized that that would be kind of a lot of trouble, and not sure that I was convinced that I would be able to explain what was going on with that. So um, I decided to try to develop some algebra and see what I could do with Sketchup and try to prove what was going on. First of all, this is the algebra for the impossible puzzle. Um, there it is in full color glory, and I decided that there were 7 important variables in this puzzle. They are A, B, and C, which are, if you can see my cursor, A is the height of this small shape here, the hot pink shape. C is the half height of that, the height of the arm of this small piece. B is the length of the arm of the small piece. And so those make up A, B, and C. But width and height are the overall width and height. Within that, there's X and Y, capital X and capital Y, which X is the width of this small or narrow but tall piece on the left side. Y is the width of the gold piece here on the right side. And then the most important variable is this variable called P, which is the height or the distance from this intersection of the blue and the gold and the top. And we get a different value of P by adjusting the slope of this line. But if we pick P, we can adjust the slope of that line. All right, let's take a look at some of the expressions that I came up with that are based on those variable values. There are 7 equations that go with those 7 variables. And they are the width, the overall width, is equal to X plus Y. Y, the width of Y, is A plus B plus A. The height of A is 2 times C, or C plus C. The overall height is equal to the length of this segment, L, plus A. Now, this is an interesting expression. Y over P is equal to W over M. So Y is the length of this segment right here, and Y and P form a small rectangle that is equivalent in shape to this larger rectangle, W and M. So the ratio of Y right here to P is equal to the ratio of W over M. Now, an important thing to realize is that P, in state 2 of this puzzle, so what we're seeing here is state 1 before it's reorganized. When we reorganize it, we move the blue shape to the right, and we stack these 2 smaller flag shapes on top of each other. And we end up with something like that on the right-hand side. And X is the left-hand side width. And what happens is when we move this over, we move it up. We move the blue piece over, we move it up by a distance of P. And so it forms a space below itself that's P tall. And when we stack the 2 flag shapes up, they are C and A. So the length of P is equal to A plus C. The length of X is equal to A plus B. And those are our 7 expressions that we have. There they are summarized. I took those 7 expressions and reworked them and solved isolated variables and solved for various variables. And I said, okay, ultimately, and I'll go through this list pretty quickly, we have a width of some number, and I say, let's say 10 inches, height of some number, say 10 inches, and P equals some variable. And so we play with P until we get a puzzle that approximates what is in the video. And by fiddling with the substitutions and in isolation of variables and all that, I came up with an expression for C, A, B, X, Y, and Z in terms of W, H, and P, or in terms of previously defined variables. So without belaboring the algebra that went into doing these substitutions, these are the expressions that I came up with. And for every dimension in the initial picture that I showed you, I came up with an expression so that I could then plug that into a SketchUp program that I wrote using Ruby. So here's my Ruby code, and I won't go into the details of the Ruby code. I'm not really a Ruby SketchUp programmer. I did learn just enough to kind of make this work. But when I run this program, it generates this puzzle for me, or the puzzle board. And so I will highlight these lines. I've chosen a height of 12. Let's make that a height of 10 and regenerate. Okay, so there's the height of 10. Before I go too much further, I want to mention that in this video, it's going to be best if we use parallel projection. and then hit Command 1 to minimize any sort of issues we have with perspective that's caused by the three-dimensional display in SketchUp. So here we have a width of 10, a height of 10, and I chose in this case p equals 2.5. If we change that, let's change that to p equals 2.0. You can see that we regenerate and we get a different puzzle shape. Let's change that to p equals 1. And so you can fiddle with this p value, which again is this distance from here to here, and get different shapes. So let's do a p equals 2. Now let's solve this puzzle with p equals 2. And we'll just take that off there, move this down, use the snapping, put this over there, put this over here. And you can see immediately that we now have some overlap down here. And this is the same result that you'll see in these other solution videos that discuss how this works. Now in this case I have a rectangle right here instead of a square, but in the video there was a relatively square shape there. So what I've done is I've written a second part of this program, which I'm going to enable right now, which will generate the solution to this video. To the puzzle. And so I have the original and the solution. And in the solution, I've drawn my overlap up here in the top. But if we want to see what that looks like by moving it down, I just move it down, and there is the same overlap that we had. And I can regenerate that, and it'll show up there. It's a little easier for me to discuss some of the aspects of the solution of this by showing the overlap up here. So again, we have our rectangular hole here, which I don't particularly like because it doesn't match the video. If we change that to 2.5 for p, 2.5 inches, and regenerate, you can see we now have a square shape here. And I'll just measure across there, 0.0694, 0.0694 inches. So it really is a square. So it turns out that p is equal to 1/4. If you make this distance here 1/4 of the width, you will get a square here. Another interesting thing I noticed here is that if we change the height of this to, say, 12, notice that the overlap that we have doesn't change. So let's measure that overlap. 0.0921. And let's change the height back to 10. Regenerate. Measure the overlap again. 0.0921. 0.09921. Just for fun, let's regenerate with 12. I said that wrong to begin with. 0.09921. So it is the same, and the overlap is independent of the height of this puzzle. So you can already see that if you make the puzzle a little bit taller than square, say 12 by 10, then the overlap here, the percentage, this piece gets longer. This gold piece gets longer. And so the amount of overlap that we have to deal with is smaller. And so you can take a piece of foam core board and bow it just a little bit, make it buckle, and you'll hardly notice at all, from a video that's just flat. The other thing that we can do is if we take this and let's say we zoom in real close, and let's just go to that point there. If we now move this down by half that distance, zoom back out, and you can see we have half the distance here and half the distance there. That makes it that much easier to kind of mask what's going on, because half of the distance is absorbed in the top and half is absorbed in the bottom, and plus you've got a little bit of buckling or bowing that you can use to hide the error in this. Let's take a look at something interesting here. If I take this and move it down so that it is in line with that and put all the overlap down here, and then I select it and draw a line across the bottom, and then select that, look at the entity info, we can see that the area is 0.04823 feet. And if we take the rectangle tool and draw a rectangle in there and get the area of that, 0.004823. So the area of that rectangle is equal to the area of that overlap there, 0.04823. And I'm just looking at this entity info inspector here. Let's do that one more time. 0.04823, looking at this thing, 0.04823. So there really is no magic here. The area of that is equal to the area of that rectangle, or that square there in this case. One other thing I want to comment on, if you set p equal to 3, in this case, with a width of 10, we have no overlaps anywhere, and there's no gaps or anything. So p of 3, this height p of 3, results in a puzzle that is completely perfect. So let's just let's just take these pieces and overlay them on the other piece so that we can see that that really is true in this case. Yep, there it is. It's a perfect puzzle with a p equals 3. So let's undo that. Okay. Now, a couple of other things. I wanted to find out if it was possible to distribute some of the space into other parts of the puzzle. So let's put our p back to 2.5. And we see our overlap here, and it's all in this one place. However, if I adjust the C value a little bit, and because of the way I've constructed my algebra, all of the overlap ends up here. But if I change the algebra just a little bit and adjust the C value by, in this case, 1/50th of an inch, I'm going to enable this and regenerate. Now you can see that we've got some overlap here. And I noticed that in the video, when the person was solving the puzzle, they struggled a little bit to get these pieces in and out. So I believe that some of their overlap was embedded in this area right in here. And now this has gotten smaller. So if we measure this length, 0.006891, whereas before, set this back and regenerate, 0.006, there it goes. You can see already that it's longer, 0.009. So by putting some of the error into other pieces, you can make this piece have an even smaller overlap. So we have some of the overlap here, some of the overlap there. And we can even fiddle with it a little bit more and put some of the overlap in other pieces. So now in this case, I've left a little bit of a gap here. And by adding that gap, which would be very difficult to see when you're running in a video with foam core board with rough edges, little tiny gap there makes these other gaps smaller or larger. So you can add some gapping here, and that will make these gaps a little bit smaller because there's less area that needs to come to be found in these pieces.